So today I have this problem on the board. We have a times the square root of n plus b times the square root of n equals the square root of 575, and we're asked to solve for the sum of a, b, and n, where a, b, and n are all integers. So to get started with this, what I want to do, when I first looked at it, I didn't know how I was going to solve this, but what we can try to do to start is to factor 575. And one little trick, you might notice that 575 is one less than 576, which is 24 squared. So we can actually use difference of squares, and we can say that this is going to be 24 plus 1 times 24, 24 minus 1, which is just 25 times 23. And that's actually pretty convenient because we want to find the square root of that number. So let's write this square root as 25 times 23. Then you'll notice 23 is a prime. We can't do anything with that. But 25 is a perfect square. So we could actually rewrite this as 5 times the square root of 23. Okay, so that's good simplification. So let's rewrite our problem now with this factored. So we have a times square root of n, b squared of n equals 5 times the square root of 23. So then just looking at this, I would say that n, let's assume that n is 23. We'll just assume that to start. So if we look at that scenario, a to square root of 23 plus b square root of 23 equals 5 times square root of 23. Then this is going to simplify nicely if we just divide each side by square root of 23. These will cancel, and we're left with a plus b just equals 5. So if we take that and we combine that with what we know for n, and we just say we want to solve for a plus b plus n, but we know n is 23, we know a plus b is 5, and so our answer is going to be 28.